Okay, so welcome back, and we're going to turn our attention straight back to that box that we were looking at. All right, we've got an x over here, and we know that the base is square, so that's also x. Now, to work out the area, the total amount of cardboard used, we're going to need to know how high this box is. Now, I'm going to put an h here. Now, I'm putting an h there. I don't want to keep that h there, but let's see if we can work out what h is in terms of x, because I don't want to involve another variable. What do I know about the volume? I know that the volume is 1,000. How do we work out the volume of a box? Well, it's just the area of the top, which is x squared, times by the height. So x squared times height is 1,000. So in fact, the height is actually 1,000 divided by x squared. Okay, so I'm not going to call it h, I'm actually going to call it 1,000 over x squared. Right, now I've got all I need to work out the total area of the box, the amount of material. Okay, let's call it C for cardboard. Okay, maybe we make it out of cardboard. Now, let's see what we're going to need. The top, we're going to need a piece of cardboard that's x times x. That's x squared. The bottom is also going to be x times x. So in fact, the top and the bottom are going to be the same. So let's go 2x squared. Each side is going to be 1,000 over x squared. Okay, how many sides are there going to be? 1, 2, 3, 4. They're going to be 4 sides. Okay, so let's multiply that by 4. And each side is just going to have an area of 1,000 over x squared multiplied by x. Okay, now that's my expression for cardboard, and I want to minimize that. If I pictured a graph, I don't know what it looks like, but suppose the graph maybe looks something like this. Okay, this is x and this is cardboard. I want to be here. What do I know about here? I know that the gradient is 0. Okay, right, so we're going to try and differentiate this thing, but before we do that, we're just going to simplify it a little bit. We get 2x squared. This here is 4,000 over x. It's actually 4,000 x to the minus 1. All right. Now we're going to differentiate it. So c dashed is going to be 4x minus 4,000 x to the minus 2. And we want that gradient to be 0. Okay. Now if we add that term to both sides, we're actually going to get 4x is 4,000 over x squared. Let's multiply both sides by x squared. So we're going to get 4x cubed is 4,000. Divide both sides by 4, we're going to get x cubed is 1,000. And then cube root both sides and we get x equals 10. Okay, and so if x is 10, then the box is actually 10 by 10 by 10, because this will be 1,000 over 100. So our best box is actually, and I'm going to write it just over here, 10 by 10 by 10. 10 centimeters by 10 centimeters by 10 centimeters. That is our best size box, which will hold 1,000 milliliters, 1,000 centimeters cubed, 1 liter, okay, but uses as little cardboard as possible. Okay, I'm going to ask you to pause the video and try this next one. This one actually says that a box, it gives us all the dimensions. And it says, what should x be to make the box as big as possible? Right, so this one's actually fairly straightforward because we've got all the 3 dimensions. How do we work out volume? We just multiply them together. Pause and have a go. Okay, so in fact, volume is equal to x times 2x, that's 2x squared, times 160 minus 3x. That's our volume. I don't know what that looks like, but maybe it looks something like this. Where we want to be here, because the derivative will be 0. Okay, that's the maximum point, and at that point, the derivative will be 0. So let's differentiate this thing, but first we've got to get rid of the brackets. 320x squared minus 6x cubed. Okay, so let's differentiate this. We're going to get 640x minus 18x squared. Okay, in fact, if we make this equal to 0, we can take out a common factor of x, and we're going to get 640 minus 18x equals 0. Right? Now, x could be 0. Now, if x is 0, our box is going to have 0 volume. All right? Or x could be 640 over 18. Now, the question is like, which one's going to give us the maximum, which one's going to give us the minimum? Remember that we can use the second derivative to check that. If we work out the derivative of the derivative, we get 640 minus 36x. 640 minus 36x. Okay, now if we put 0 in here, we actually get a positive value. We get 640, which means that the graph is concave up like a cup, and that's a minimum value. In fact, what this graph actually does, it actually does something like this. Okay, we can't have negative values, but it actually has a minimum there. If we put 640 over 18 in here, we get a negative answer, which means that the graph is concave, down like a frown, which means that the maximum occurs at 640 over 18. So x equals 640 over 18 gives the maximum volume. Okay, right, let's have a look at question number 4. Right, this is a fairly straightforward one. So is number 5. All right, try both of them. Pause the video, try both of them, and then let it play again. Okay, so this, we actually know what this looks like. This is just a parabola, isn't it? And we want to be there. What do we know about the gradient there? We know that the gradient there is 0. Okay, so we're going to differentiate this thing. Y dashed is going to be negative 4x plus 5. We're going to make that equal to 0. So we actually get negative 4x equals negative 5. Divide both sides by negative 4. Remember, negative divided by negative is positive. So we get x is 5 over 4. Right, that's not the minimum value of y. That's the value where the minimum occurs. That's the x value. Where must we put that x value to find the y value? Not into the gradient. Here, into the function that gives us the y value. Okay, so let's do that. So we're going to now take, just trying to make sure that you're seeing everything you need to see here. Okay, so we are going to put 5 over 4 into this equation. So negative 2 open brackets 5 over 4 squared plus 5 open brackets 5 over 4 plus 11. And we get 14,125. Right, 14,125. So the maximum value, all right, I've just realized I've drawn a really silly graph here because I've drawn this graph the wrong way up. All right, obviously this graph is actually a concave down graph. Okay, we know it's a concave down graph because it's got a negative value at the front here. All right, the maximum value of 14,125 that's the biggest it ever gets, and that happens when x equals 5 over 4. Okay, right, question 5. If you didn't manage to do question 4 on your own, try question 5 now. Just pause the video and try it, and then let it play again. Okay, so question 5. Once again, this time it actually is a concave up parabola. Okay, and we're looking for a minimum value. At this point, we know that the gradient is 0. So we're going to differentiate. We get dy dx, or y dash, is 6x plus 12. All right, we want that to be 0. So 6x is minus 12. If we subtract 12 from both sides, x is minus 2. That's the x value of that point. To find the y value, we're going to substitute minus 2 in here. We're going to get 12 minus 24, that's negative 12, plus 115. I think we get 103. 103. Okay. All right. So let's look at another one now. This is a slightly different one. We haven't got a box, we haven't got a rug, we haven't got a field. We've got the sum of two positive numbers is 100. Okay, so let's let one of them be x. All right, now remember that they add to 100. So if we just temporarily let the other one be y, we know that y plus x equals 100. So in fact, we know that y, the other one, is actually 100 minus x. Okay, so if the one is x, the other is 100 minus x. Right. It's quite possible that we don't really need this, okay, but maybe we do. So, all right. Now, we want the, sorry guys. Okay. We don't want the sum to be 100. We want the product to be 100. Okay. So the product must be 100. Okay. So x times y must be 100. So the other number must be 100 divided by x. Okay. So the one number is 100 and the other one is 100 over x. The sum, let's call it S for sum, is just going to be x plus 100 over x. Okay, I don't know what that graph looks like. Okay, but the question suggests that it's going to get as small as possible at some point. So I really want that there. Let's move that up. Okay, this is the sum and this is x. Where do I want to be? I want to be there. What do I know about the gradient there? I know the gradient there will be 0. So we're going to differentiate this thing. It's not flat at the moment, so let's make it flat. It's actually x plus 100 x to the minus 1. Let's differentiate it. We get s dashed is 1 minus 100 over x squared. And we want that to equal 0. Let's add the 100 over x squared to both sides. So we get 1 equals 100 over x squared. Let's multiply both sides by x squared. And let's square root. And so the answer is that x equals 10. So the one number is 10 and the other number is 100 over 10. So in fact, the best answer is for both numbers to be 10. Okay, right. We're going to stop there. Slightly shorter lesson than normal. But we'll carry on tomorrow and we will look at question number 7 and you might want to try it yourselves in the meanwhile. But either way, we look forward to seeing you next time.